Welcome back to Math and Beats. In this video, we are going to show and introduce how we can solve equations and inequalities graphically. So, here we go. First thing, let's just get a setup here. Let's suppose that we have an equation right here. It's of the form some function f of x equals some other function g of x. Well, we could graph each of these functions, as we can see in the diagram that's provided. In the blue, that's the graph of f of x. And in the yellow, orangish looking color, the graph of g of x. So, we could solve this equation by graphing each side of the equation as its own function of x, and then finding where both of these functions have the same output. In the diagram that we see, these are at the x locations. X is A and x is B. Hence, the solution to that equation, f of x equals g of x, is found graphically by finding where they intersect and looking at the values of x which do this. X is A and x is B in this particular example. So we're going to try that in a bit with an example. But now let's suppose we have the same two functions and we wanted to solve an inequality. Say f of x is less than g of x. We can replace that inequality symbol with less than or equal to, or greater than or equal to, or greater than, and depending on the inequality symbol, we would be looking for different x values. But in this particular setup, if we're looking at where the function f of x is smaller than g of x, then we're going to look at where this function f of x in blue is smaller than, hence below, the graph of the g of x function in the orangish yellow. Where is that going to be? Well, the function f of x, its graph is below the graph of g of x, all on that piece of the graph right there. So we're trying to solve the inequality in terms of x. Which x values do this? All the x values between a and b, but not including a and b because we're looking at just where it's f of x is less than g of x, not less than or equal to. So the solution set to such an inequality would be all the values of x between a and b and not including the a nor the b. Hold on one sec. Coffee sip. Yes. Okay, so we're going to look at some examples of this first and then try one on our own with some technology. And here's an example. Suppose we wanted to solve the equation x squared equals square root of x, but doing it graphically, so no algebra involved. Well, like we set up earlier, we're going to let the left-hand side be f of x, so we're going to call left-hand side x squared is f of x, and the right-hand side g of x equal to square root x. So really when we're solving this equation here, x squared equals square root x, it's just like the general situation, where does one function equal another function? And we plotted them. They were already provided, but I'll show you in a moment how you could plot one by yourself using some software. And they're plotted there, and we can see that these two functions' graphs intersect at 2 points, one of them being right there when x is 1, and the other one being down there at the origin or when x is 0. Hence, the solution to this equation is found by finding those two intersection points. And what x values do that? X is 1 and x is 0. Now you see down below, there's an alternative way of approaching this, which we can always do if we felt like. Might as well show you. So far, we saw that you just plot both the left side of the equation and the right side of the equation, treat each of those expressions as a function of x and graph them and see where they intersect. But what if we brought one of the sides to the other. What I just circled down here is the result from taking the original equation and subtracting square root x on both sides. Once I do that, I would get the equivalent equation x squared minus square root x is equal to 0. So whether I solve the equation in its original form, or if I want to bring terms and expressions to one side or the other, it doesn't really matter. The original equation is equivalent to this new equation where 0 is isolated on one side of the equation. And the advantage of this is perhaps it's hard to see where two graphs intersect. Instead, we could think of this entire left-hand side now as some other function, say h of x, and looking at where that thing's graph actually intersects the x-axis. It will produce the same solution set. So in the graph that we're about to look at below, we better have the solutions x is 0 and x is 1. And indeed we do. So right there in this picture here, what you see is the graph of the function, called it f of x, but maybe let's just call it h of x because, you know, we already had an f of x above. But regardless of what you call it, the graph of x squared minus square root x looks like what's graphed in the picture. Oh, look. It intersects the x-axis, hence when the function equals 0, at the exact same x values as above. X is 0 and x is 1. Those are our solutions. And in any given situation, when we're trying to solve an equation or inequality graphically, we can always choose to move all the terms to one side and seeing where it equals 0 or above or below the x-axis depending on what we're asked. And as you can see in this part B here, instead of looking at the equation x squared equals square root x, we're now asked to find where is x squared less than square root x. Well, again, that's going to be on the part of the graph where the function x squared is below the graph of the function square root x. Where is that? It's all along that piece right there. Which x values produce that part of the graph? The values of x between 0 and 1. So the solution set to this inequality would be all values of x between 0 and 1, but not including the 0 or the 1. Equivalently, if we chose to now bring everything to one side, like we did previously, x squared minus root x all on the left side, by subtracting the root x on both sides of the inequality, the solution set to the original equation, inequality, x squared less than root x, is going to be the same solution set to figuring out where this function x squared minus root x is less than 0, or negative. There's our graph again, and indeed, that function's graph is below the x-axis for all these values between 0 and 1, but not including 0 and 1. So two approaches given the same solution set, solving the inequality graphically. So what we want to do now is look at a situation in which we don't have the graphs provided, but we have to go create the graph. So there's many ways we can do this, but I'll show you one. In this example, we're going to solve an equation and an inequality using graphical methods. We'll see the equation inequality here in a moment. And because we're about to see some functions that are not obvious what their graphs are, we're going to use some graphing software to help us. So what are the equations and inequalities? Is these two right here. So when does 5x squared minus x cubed equal negative x squared plus 3x plus 4? And where does 5x squared minus x cubed less than or equal to negative x squared plus 3x plus 4? For the sake of this, we can call one of the left-hand side here f of x. So f of x is 5x squared minus x cubed, and the right-hand side g of x being negative x squared plus 3x plus 4. And we're going to go and graph these two functions, and we are going to look at where they intersect. And then we'll look at one is less than the other or equal to. Now, before we do this, just remember, we could choose to also take the original situation. There's the original equation which I'm writing, and bring all the terms to one side. So for instance, if I added x squared to both sides, if I subtracted 3x to both sides, and if I subtracted 4 to both sides, then what I would get is, on the left-hand side, 5x squared plus x squared is 6x squared, and then negative x cubed has no terms being added to it, so it's just minus x cubed still, and then minus a 3x minus a 4. On the left-hand side, we could also try to figure out when does that function actually equal 0, if we chose to. All right, so what we got to do right now is graph these functions using some device. And what I have already kind of set up is the graphs using software which is called WinPlot. And the WinPlot, as we can see here, I've already provided the graphs, which I'll go and copy paste into my document in a minute. But this is a free software specifically made free for Windows users. So WinPlot, WinPlot. It's a pretty decent software that's easy to use to do some basic stuff like graphing functions of one variable and whatnot. More coffee. Oh. All right. So there's the two graphs. Let me just copy this thing into my document so I can write on it and stuff. I'm going to do Bitman to clipboard. Graph it right here. And boom, there it is. So which graph is which? Well, I happen to know that the blue graph is the graph of g of x, because it's quadratic. G of x is negative x squared plus 3x plus 4. And the red graph is the graph of that cubic function, that's f of x, which is 5x squared minus x cubed. And so we can see in the graphs, we can eyeball where these two functions intersect. Again, we're trying to find where they intersect because we're trying to figure out where they equal to each other. And just by eyeballing it, I'm drawing in these dots here, right there, and right there. Those are 3 points where these two functions intersect. What are the x values there? Well, they're not nice x values like we saw in a previous example. There's some approximation. So at this one, we just have to try to approximate. It looks like that's maybe about, I don't know, x is about 1.2 or so. And then the one on the far left, that looks like just about maybe negative 0.6. So x is approximately negative 0.6. And then finally, down at the far right, at the bottom there, that x approximately maybe about 5.2. So we can say that the solution set to this equation is x is approximately negative 0.6, x is approximately 1.2, and x is approximately 5.2. Now that's about as good as we can get without using some advanced algebraic techniques or just by eyeballing it. If you do go back to the graph over here in the software, you can click on the points to get an idea. Like that one's about negative 0.57 for x. This one's about 1.3, and the one down here about 5.2. So just by eyeballing it, we did pretty good. We get more exact by actually clicking on the software values themselves. Now, to also see the inequality, well, we have the situation already set up. Remember, our left-hand side is f of x. Where is that less than or equal to g of x? We're going to look at the part of the graph, the red graph of f. Where is that below the graph of g? And if we just go and look, we can see that the red graph is below g on that little squiggly part that I just drew. And then also down here on the far bottom right, the f of x is below g of x forever after that. So you say, which values is this function f below g of x and also equal to g of x, the inequality being less than or equal to, that's going to occur for values of x between negative 0.6, at least approximately, and everything all the way up to and including approximately 1.2. That was not a good bracket. There's a better bracket. And then also it starts happening again. So union with 5.2 all the way to infinity, since f just stays below g forever after 5.2. So we did it. We graphed a couple functions and we figured out graphically where an equation is true by considering left and right hand sides as different functions. Now just quickly to go back to the software here, you can see that I had input those functions into my little dialog box. I'm not going to give a whole tutorial on how to use WinPlot right now, but you just tell it what to graph, it graphs it. Now I'm going to hide those real quick. And then what I'm going to graph is this function right here. Look closely. That is actually the graph of the function where we brought all the terms to the left-hand side. What does it look like? Looks like that. So I'm going to do another bitman here and copy it to our page over here. And there you go. What is that the graph of? That's the graph of f of x minus g of x. So remember what that was. We had already figured that out up here. 6x squared minus x cubed. 6x squared minus x cubed. And then minus a 3x minus a 4. So we brought all the terms to the left-hand side. This thing better equal 0 at the same locations for which the two functions were intersecting originally. Remember, this is the alternative approach of getting everything on one side of the equation or inequality and looking at where it's at the x-axis above or below. So where is this function equal to 0? Well, same spots as before. Check it out. Right there, that was x is approximately negative 0.6. Right there, that was x is approximately 1.2. And then over there, that was x is approximately 5.2-ish. Nice dot. 5.2-ish. So, look, same values. Is it easier to look at where they intersect or where one function crosses the x-axis? That's total personal choice. Both ways will work. Might as well just do the very last piece, and that was the part B was asking, well, where does this function f of x minus g of x, where is it less than or equal to 0? Because remember, before we were asking where f of x was less than or equal to g of x. Bring the g of x to the left-hand side. Now we're asking where the difference in these functions is 0 or below 0. Where is it below the x-axis? All along that piece right there. And then over there where I squiggled. Hey, guess what? Same interval as before, as it should be. Approximately the answer to this inequality would be for x's belonging to the interval negative 0.6 to 1.2 union with 5.2 to infinity. So you could do this for any equation and inequality. As long as you have a graphing software to do such things. There's probably other ones out there on the internet you can find whatnot that you may like better than the one I've chosen to use. But this one is simple enough, at least for Windows users. And this is a nice tool to have when you're solving an equation that maybe does not have trivial answers or involves some advanced algebraic techniques and whatnot. We could always do this to at least give us a pretty good idea about where the solutions could be, if not the exact locations, depending on the solution set we get. So that's it for this video. I hope that the video was helpful, and please make sure you stay tuned for more videos and more beats. And if you like the videos and they help you, please press the thumbs up and subscribe, especially if you like the beats. Get them beats coming. All right.